Again, good afternoon class. Tutuloy lang natin yung lesson natin and this is the last topic for the first exam. Okay. So after nitong topic na to, exam na tayo. Alright. Sa lab, nakapag-try na tayo ng isang nonlinear element tulad ng diode. Okay. So ngayon, di-discuss natin siya in depth. Okay. Yan. So what else? Okay. Start tayo. Diodes. Okay. Ang diode symbol natin, nakita na natin to sa lab, will be this guy. Okay. Yung plus terminal would be this side and yung may bar would be the negative terminal. And then in the experiments, usually yung mga diodes, yung paa nila, hindi magkasing haba. Yung mas mahabang paa would be the positive terminal and yung mas maikli would be negative. Okay? Or minsan naman, hindi pantay yung shape ng diode. Minsan nakaganyan. Pag tinignan mo sa taas yung diode, medyo nakaganyan siya. So ito yung positive terminal. And so on. Okay? Okay. Formally, yung diode equation natin is usually given like this. Okay? So ID is the diode through the ID is the current through the diode. Okay. And then VD would be the voltage across the diode. Okay, ano itong mga VTH dito tsaka IS? Yung IS and VTH are constants. Nakadepende yan sa stats no, sa properties ng diode mo. Okay, si IS, pangalan niya ay saturation current and it's usually around 0.02 milliamperes. Okay, pero given naman yan. Minsan, given naman yan. Hindi naman ako magbibigay ng mga plug and play na tanong. Solve for BTH, mga ganun. Walang ganun. Madali masyado yun. Okay? So, yung IS is, pangalan niya, saturation current. Saturation current. And then, VTH is also a constant of the diode, property of it. Ito ay thermal voltage. Okay, so it's something that depends on temperature. And ibang sources, VT ginagamit nila kasi ginagamit natin ito for Thevenin voltage. Diba pa? Ang hassle naman kung parehas. Okay. And then the response of a diode is, as we can see here, is nonlinear. Okay? Yung mga resistors natin, di ba, pag ganun sila or pag ganun, and other elements such as source, ganun din sila. Pa-vertical nga lang pag source, etc. etc. Okay, mapapansin natin dito that whenever your voltage is negative, almost zero yung current sa diode. Okay? Very small. And then kapag positive ka na, saka lang dumadalo yung current sa kanya. Okay. Alright. Now, ang problema sa mga nonlinear, bakit natin sila yung inaaral? Mga nonlinear element, kasi itong mga nonlinear element, hindi nila sinusunod yung mga techniques na ginawa natin tulad ng superposition, pati Thevenin and Norton's theorem. Okay, kasi si Thevenin and Norton galing lang naman sa superposition. So kung di siya gumagana sa superposition, hindi rin siya gagana sa Thevenin and Norton. Okay, si KVL at KCL gumagana yun sa lahat. Okay, dahil property yun ng electromagnetism. Okay, so KVL is yung KVL natin, product siya ng KVL is a product of yung, naalala nyo pa, hopefully, yung potential, di ba? Line integral siya ng electric field, and kapag umikot ka, bumalik ka sa starting point mo, VAB is 0 kapag B is equal to A. Okay? So, kapag umikot ka, ayun yung KVL mo. Kaya, in-equal natin sa 0 yung voltages. Okay? KCL is just a product ng conservation of charge. Okay? Okay, so ayan, gumagana pa rin sila, yung KVL at KCL. Problema nga lang natin, itong mga processes na to, di ba, ayaw nga natin sila kasi ang effort nila bigay ng solution. You'd have multiple lines of equation na karamihan sa kanila, di naman useful kasi restatement lang siya ng ibang equation. Okay, so for nonlinear circuits, kailangan natin ng mga bagong techniques to solve for our problems. So meron tayong apat na i-discuss na techniques para sa mga nonlinear elements. First things first is analytical solutions or brute force. Brute force. Kasi isosolve mo siya mano-mano and gamitin mo KVL, KCL, you have equations and try to solve for the thing that you need. This is the safest way to solve. Pero tayo ay hindi naman mga computer and not all of us have time to magpakabatak para sa mga math equations natin. This is usually impractical dahil ang hassle niya. Okay, so let's try for this nonlinear resistor. Yung properties niya would be ID. Yung current sa kanya would be K times VT squared. So nakadepende siya doon sa voltage niya. Tapos square yung voltage na relation niya. Okay? So kapag positive yung VD mo, meron siyang value. Kapag negative yung VD mo, or 0, kasi pag pinlagin mo yung 0 dyan, mag-0 din yung ID. Mag-0 siya. Okay, ano itsura nito kapag dinrawing natin? Kapag pinlot natin yung properties ng nonlinear resistor mo, we have this. So let's plot VD versus ID. Okay, ideally, di ba meron kang KVD squared. ID is like KVD squared. So kung in math notation, di ba, parang ito ay y is equal to ax squared. Okay? So meron kang quadratic. Okay? However, meron kang restrictions. Anong restrictions natin? That would be, kapag nandito ka na sa left side, pag negative na yung VD mo, 0 na din siya. So, burahin natin ito. May nabura lahat. Ano ba yan? So, for this part, 0 lang siya. And then, magiging quadratic. Okay, quadratic. Ayan. So, ganyan itsura ng response nung nonlinear resistor mo. Alright. Let's proceed to the math. Okay. So, node analysis tayo. We're safe to do node analysis dahil shortcut lang naman yung node analysis from KVL and KCL. Let's do node analysis here. Yung pumapasok na current would be E minus VD divided by R. And yung lumalabas na current would be ID. Okay? Okay, kuha lahat yun, Agree lang yan, di ba? And then, we know ID to be like this. So, I just write them down. Okay. So, meron tayong VD on the left-hand side and VD on the right-hand side. Ayusin lang natin lahat-lahat. We actually get something like this. A R V D squared plus VD and then minus E must be equal to 0. Nire-rearrange ko lang, no? Walang bago doon. And this sort, mukha siyang ax squared plus bx plus c 0. And how do you solve this? Quadratic equation. So VD must be equal to negative 1, kasi yung B mo dito ay 1. Then plus or minus square root ng B squared minus 4AC, di ba? B squared minus 4AC. So B is 1 again. 1. And then minus 4. Ano yung A natin? KR. And then C would be negative E. So this becomes positive. And then all over 2A. 2A is just 2KR. 2KR. Okay. Brute force, di ba? Solve tayo by math. Now you have two values for VD. Meron kang plus na square root and minus square root. Okay. Problema ngayon, paano mo pipiliin yung sagot, ang tamang sagot. Okay, let's have a look. Tingnan muna natin kung ano pa yung mga equation natin. Balik tayo dito sa unang-una. So, kunin natin to. Tingnan natin. Tingnan natin to. Tapos itabi natin siya dito. ID is also equal to, ano nakalagay doon? E minus VD over R. E minus VD over R. R is a constant, E is a constant. Therefore, this equation is linear. Okay? So, i-plot lang din natin to. Tingnan natin kung ano yung mga mangyayari. Okay, paano ka magpa-plot ng mga ganito? I-zero mo lang yung mga variables mo muna, no? Tapos alam mo namang linear siya. So, connect the dots na lang. So, for ID is equal to 0, bale, dito ako magpa-plot sa VD na line. Kasi bababa ko ng 0 si ID, di ba? Okay. At ID equals 0, we have V minus VD over R. Therefore, this tells me that VD must be equal to E. Okay, so, lagay tayo ng E. Okay? And then, we do another one. Kabila naman yung is 0 mo. VD equals 0. So, magpa-plot ako dito sa line ng vertical axis. Okay? Magiging ID must be equal to E over R minus 0. Okay? Therefore, ID is E over R. Somewhere here, sabihin natin dito, E over R. Okay? And then we have that line. Ay, blue pala dapat. Natin blue. Para cute. Okay, blue here. Ay. Okay, ayaw na magpalit. Ito na naman tong error ng ano. Okay, ayaw niya. Sige. Pagbigyan natin. E over R. And then I just connect this line. Okay, and then meron tayong intersection. So that is a solution. And then, itong sinolve natin dito kanina is a quadratic equation. So this actually solves for, yung sinolve natin is actually for this guy. Okay, so nandun pa yung remnants nung pinutol natin na left-hand side nung resistor properties. Kung mapansin nyo, yung line na to would extend here, and the other solution lies there. Okay? Dalawa yung solution mo. Yung intersections ng mga yan, ayun yung mga solution. Ito, tsaka ito. But this is not attainable dahil nga yung actual properties ng resistor mo is going through this line. Okay? So we have to take this part of the solution. Okay? And that tells us that we have VD to be negative 1 plus 1 plus 4KRE 2KR. And we have solved for the current. We just plug in this VD there. Okay, so i-square mo lang to, pasok mo sa equation na to, you have solved for ID. Okay. VD. Check. Okay. Okay. Sa exam, baka maano kayo, baka makalimutan niyo yung mga tanong. Kuwari, tinatanong pala yung ID, tapos hindi, yung VD lang yung sinolve mo. Siyempre mali, di ba? So, ibabalik mo pa rin. Okay? Sulat mo pa rin. Lagi ako namamali nung undergrad ako na gano'n. Kasi na-excite ako i-solve yung bulk nung problem. Tapos nakalimutan mo na ano pala yung tinatanong. Okay? So, don't forget that. Alright. So, nice, no? Dali lang pala, sir. Dali lang pala non-linear elements. Let's try another one. Sir, lagi na po bang iti-take yung positive solution since hindi ito violated yung property ng nonlinear resistor? Not necessarily, not necessarily. Kuwari, binigyan tayo ng nonlinear resistor na ganito yung properties. Kuwari, pabaliktad yung property niya. Ganyan. Okay? Kuwari pa ganyan yung property ng nonlinear resistor mo. This is ID. This is VD. Then, pag pinlot mo yung line mo, dalawa pa rin yung tatamaan mo. Now, you have to get two solutions. There are two valid solutions. Okay? Dito kasi, na-miss out niya na isa kasi binago natin yung properties ng resistor. Okay? Yung resistor kasi ganun siya sa left-hand side sa negative na VD. Okay. Tsumamba lang tayo na for this problem, isa lang yung tinamaan, isa lang yung intersection nila. Okay. Pero pag ganito na yung problem, dalawa yung solution mo. Yes. Hindi lahat ng nonlinear element na ganun yung itsura. So, ibibigay sa'yo kung ano yung problema mo. Minsan weird yung problem. Minsan sinusoidal yung response niya, ganun. Okay? Anything can happen. This is specific for this example. Okay. Okay. Let's proceed. Let's try a harder example. Okay, ganito na. Kanina dali, di ba? Kasi isang ikot lang yun. Ganito pa. Paano mag ganito? Okay. Now, alalahanin natin na yung superposition, hindi siya gumagana pag gagawin mo siya sa isang nonlinear element. Ano ibig sabihin nun? Kapag kasama siya dun sa circuit na ginagalawan mo, like siya yung kukumputin mo yung resistance niya, hindi siya pwedeng ganun. So you have to pag tinake out mo na siya ngayon sa system mo, then you can still do the superposition for the other parts of your circuit. Okay? Okay. So anong ibig ko sabihin? Sige, i-detach natin to. Kuwari, dinetach mo yung circuit mo sa kanya. Okay? Tapos, yan siya. Ito yung nonlinear, nonlinear resistor mo. Dinetouch natin. Okay? Now, this whole thing is linear, di ba? Linear na ulit to. Then I can proceed to simplifying this network. Titingnan ko na lang kung ano epekto niya dito sa mga wires na ito. Okay? And yung pagsisimplify na ganun, di ba, our trusty friend for this kind of problem would be this simplification. Yung Thevenin equivalent circuit natin. Okay? Or Norton kung gusto mo. Pero mas appropriate dito yung Thevenin. Okay? Okay, may tanong. I-open ba yung part kapag i-remove siya sa circuit? In the process of simplification, yes. Pero kasi nakakonect, ang hirap nung tanong. Hindi ko maano yung hindi ko Okay, yes yung safe answer. Yes. Okay. Okay, continuing. So ang goal natin for this problem is to simplify the other parts of the network so that magagamit natin yung mga previous theorems natin in solving for circuits. Okay. Now that we can have this kind of circuit, kung saan nakadetach na yung nonlinear element mo, we can proceed in simplifying this. Okay? Sige, solve natin. First things first, anong kailangan ko? VTH tsaka RTH. Kapag VTH, ano mangyayari? Babaklasin mo yung circuit. So yes, ayun na yung tanong. Babaklasin mo yung circuit. Tingnan mo kung ano yung epekto ng voltages dito sa mga nodes na ito. And then, dalawa yung voltage ko, dalawa yung source ko. So I can use my superposition para masolve itong problem na to. Okay? So, okay. So, unahin ko muna yung VTH1 wherein naka-turn off yung I. Okay, pag tinurn off natin yung current source, ano mangyayari? Mababaklas siya, di ba? Magiging open circuit siya. Therefore, yung resulting circuit natin would look like this. 5 ba yun? Joke, bilang. Asyumera. T. Tapos, resistor, R2, this R1, R2, and then oops, mali. Yes, ang ganda mag-drawing. Yan. Okay, so ganito na itsura. Unang-una, dahil VTH yung pinakalculate ko, detach ito, so open circuit siya. And then pinatay ko si I, so maging open circuit na rin siya. And yung resulting na lang would look like this. Okay, okay, okay. Okay, and then all of this is connected to the ground. Therefore, anong mafe-feel ko na voltage dito? Okay, dito walang dumadaloy na kuryente. Therefore, ang voltage nito, kukunin niya lang yung voltage na nakadikit dito. Kung saan siya nakadikit. So this is 0 volts. 0, 0. And then for this part, anong voltage na makukuha ko dito? Voltage divider. Tama? Voltage divider ito. So, VTH1 VTH1 is just this voltage minus this voltage. Okay. The voltage divider ko would be like this. V. And then minus 0. So this one minus this one is this. Okay. So tanggalin natin to. Kasi 0 lang naman. Okay. Next one is VTH2, which is V of what happens to our circuit. Magiging wire lang ito. And then let's redraw the system. Wire. Tapos resistor. Resistor. This is like that. Like that. I not. And nakalimutan ko. Hanggang dito. Okay. R1, R2, R3. Okay. Ngayon, this is 0 volts. Tama? Kasi walang dadaloy sa kanya. Tapos, kukopihin niya lang yung potential nung kung saan siya nakakabit. Which is 0. Okay? Kung di kayo convinced doon, pwede kayo mag-KVL. You'd find that 0 yung possible solution. Okay? Okay. Kung medyo nabilis lang kayo doon, pwede kayo mag-KVL to ensure na 0 talaga yan. Next would be calculating the voltage here. Okay, madali yung voltage dito kasi this is just your Ohm's law. So this guy is, rektahin na natin, VTH2. VTH2 must be equal to 0, itong part na to, minus this part, minus, and then the voltage here is just Ohm's law, I0 R. Okay? Kuha, IR3. Okay, kuha. Pag ganun yung current, Therefore, this is I naught R3. Ohms na lang. And then, nakuha ko na si VTH. VTH ay just combination ng dalawa. VTH would just be the combination of those two, which is yung voltage divider mo. R2 over R1 plus R2, 2 times V minus I naught R3. Okay, so in-add ko lang silang dalawa. So that's my VTH. And then RTH. For RTH, ang gagawin mo, papatayin mo lahat ng source. Tama. Nalagay nyo na. Patayin nyo lahat ng source. So that's, redraw natin para hindi tayo naguguluhan. RTH would be turning off all sources. So yung left hand na source natin, yung voltage, naging short circuit na lang. And then you have something like this. And then, ito na-detach yung current source. So detach. Okay, so this is R1, R2, R3, and this is just R1 parallel with R2. Then this whole thing is in series with R3. Okay? So that's my effective resistance or my RTH. Kuha, bakit ganito? Okay, ito madali lang, gets naman ito. Na R1 and R2 is parallel. Kasi magkadikit yung ulo nila, magkadikit yung puwet nila. Okay. Okay. So, kapag pinagsama mo na yun, magiging ganito na siya. So, this guy is R1 parallel with R2. And this guy is R3. And you can see that these guys are in parallel. Ay, in series. Okay? In series. So, plus R3 lang siya. And therefore, in a more explicit way, kung paano ko siya isusulat sa calculator, ito siya. And now, babalik na tayo sa Thevenin equivalent circuit mo, which just looks like this. VTH. Okay? So, meron na tayong value for VTH. Hindi natin sulat dyan. And then RTH. Tapos saka mo ikakabit si nonlinear resistor mo. Okay? Kabit mo siya dyan. And what does this look like? Yung problem natin kanina, di ba? And ito rin yun, di ba? So, nasolve na natin siya technically. You just have to repeat everything and replace the variable. So, gagawin mo lang VTH yung E. And then, si R, gagawin mo lang RTH. Okay? Okay. So, ito, plug-in mo sa kanila dyan. So, malaki problema mo, di ba? Pag pinlog-in mo siya dyan, lalo siyang nagiging complicated. Okay. Let's try another example. Okay, may question. Sir, naguguluhan po ako sa VTH. May papatayin po pala na independent sources kapag kumukuha ng VTH sa Thevenin. Bakit parang wala naman po tayong pinatay dati nung last po na discussion? Okay, guys. Pinag-combine ko yung tawag dito. Superposition tsaka Thevenin, ha? Medyo mabilis yung ginawa kong part na yun kasi wala lang. Okay, pwede mo pag-combine yung mga bagay-bagay, no? Pwedeng yung small part lang na ito yung i-Thevenin mo, tapos small part lang na ito yung Thevenin. Pag-combinein mo, and you'll actually end up with something kapag inulit mo sila, babalik ka rin sa simulang, sa end goal mo na ganito. Okay. Okay, gets ba? Kung bakit naging ganun yung, ba't may mga patayan ng mga sources? Kasi nung pagka-Thevenin ko, it would be easier for me to pwede ko naman sila hindi patayin. No? Pero again, meron na akong technique na superposition, why not use it? Okay? Dahil linear naman itong mga elements ko dito. Okay. Sir, saan po ulit ipa-plug in after yung makuha equivalent circuit? Okay. Yung nakuha nating Thevenin equivalent circuit, ganito itsura niya kapag pinattern mo dito. Ganito siya. Minus. So this is your VTH. And this is your RTH. And ayan, as is. Lalagay mo lang siya dito. Okay? Ayun ba yung tanong mo? Sorry. Ayun ba yung tanong mo? Baka hindi ko lang na-gets yung tanong. Kasi ang tanong sa atin, saan po ulit ipa-plug in after makuha yung equivalent circuit? Did I get your question? Equation yung tanong. Okay. So, after nito, ito na yung nakuha natin, di ba? So, meron tayong similar circuit. So, tandaan nyo itong circuit na to. Kamukha niya to. Okay. But this time, E lang to, tas R. Okay. So, magiging R is equal to RTH. Kasi same solution lang naman to, di ba? So, same circuit, same solution. VTH. Okay. So, itong solution natin, papalitan mo lang si E ng VTH. Magiging negative 1 plus 1 plus 4K RTH VTH. Ito ba yung tanong? Sorry. RTH. So, this guy is the solution for this problem. Okay. Nakuha ko na. Yes. Anyway, let's have another one. Na equation. Na problem. This time, ang gagawin natin is this one. May diode tayo. Okay, again, yung diode na current is IS times E raised to VD. VT na lang, no? Kasi baka malito tayo sa VTH. Minus 1. Okay? Now, let's try to solve this equation. Let's try to solve the circuit. Dito tayo mag-KCL with our node analysis. So, that is E minus VD over R must be equal to ID. Okay? Yung coming in equal to going out. Now, I just plug in ID here. And as you can see, VD, VT, ganyan siya, di ba? Now, how do you solve for VD? Problematic to, di ba? Dito, simpleng solving lang. Hassle. Well, pwede naman solve computer, di ba? Pero hindi naman tayo laging may dalang computer. So, not every time analytic solution. Hindi siya useful every time na gagamitin mo siya. Okay? So, you must have another way of solving things. Let's try another one. Graphical analysis yung pangalawa nating technique. Okay. So, solve natin itong circuit na to using graphical analysis. Alright? Nakuha na natin itong dalawa, no? Ito, yan yung kanina. Ito yan. Diba? Ayan sila. Ang gagawin mo lang pag graphical analysis, mag-graph ka. So, let's try to graph our equations. Itong diode current mo is something like this. Exponential. And then, again, pag tinry mo itong i-0-0 yung mga bagay-bagay, pag zinero mo sa ID, ang makukuha mo ay E. And this is E over R. And then, you graph this also. I-graph mo lang din siya. You can see that you have something like this. Okay? And then, meron kang intersection. So, dun mag-exist yung solution mo. Okay? Kesa dito, di ba? Paano mo isa-solve to pag ginawa mo siyang analytic solution, it's not very insightful. You're not gonna get your intuition here. Kapag ginawa mong graphical analysis, then you can start, no? Start na mag-solve. Okay? Pag nakakuha ka na ng ganito, parang malapit sa kalahati ng E, no? Kalahati ng E. So this is E over 2. And you just try to plug in things. Plug in mo E over 2 dyan, E over 2 dito. Okay? And mapapansin nyo, yung sagot, they would seem to approach each other. Okay? Then you can approximate the current that is flowing through this circuit, through this diode. Okay? So, ganun gumamit ng graphical analysis. Okay, let's try another example para naman parang focus lang to. Focus lang to ginawa natin. So, ito pala yung graph. Nagpakirap pala ako. Ito may exact values siya. Okay? Kawari, nag-try ka ng 0.6 volt, tas lumabas. Makita mo 5 amperes, ganun. Okay, so magta-try ng values until mag-converge sila into a single answer. And that will be your solution. Okay. So useful to itong graphical analysis if you just want to see the properties of your circuit. Let's try the half-wave rectifier. Ang source natin ngayon is a cosine wave. Cosine wave siya. So yung mga values ng potential mo would be from negative E0 to E0. Okay? Kasi yung values ng cosine mo, di ba, negative 1 to 1. Masayaw lang siya sa mga values na ganyan. For this time, pinagpalit natin yung diode and yung resistor. Kasi ito kanina, di ba? And now we want to measure the potential across the resistor. Okay? Ayan. Sige. Siyempre mag-graph tayo kasi hindi natin masolve yung problem. Okay. Sige, graph tayo. We need a bigger graph. Think pala lang naman. Think yung coordinate systems. VD, tapos ID. Okay, and then you have a diode. Therefore, yung VDID yung VDID yung tawag dito. Ginagraph ko. So, I still have my diode graph, which is something like this. Okay. Actually, gandaan ko pa yun. Gagawin ko medyo ideal yung diode. So, meron tayo something like this. Yung maximum na ma-reach na diode voltage. So, this is VD. Yung maximum na niya. And then, what else can I do? Yung ID mo, ganun pa rin, meron ka pa rin ma-measure na something linear. So, let's have that. Meron ka pa rin E not over R. Then we have another one here, E not. So may max E not tayo. Tapos syempre meron din dito sa kabila na okay, medyo malayo lang. Wag na. Okay, dahil yung source mo ay cosine, so pwede siyang mapunta dito somewhere values between here and there. Okay? Okay, continue natin. Graph lang muna tayo. So, ginagraph kong itong linyang ito for the maximum value. Maximum value nung source natin. Okay? Okay. Now, mapapansin nyo, magki-KVL lang din ako dito. Let's try do a KVL. My KVL, clockwise gagawin ko. So, negative VI, then plus VD plus VO. Therefore, I have my VI, ay mali, equal to 0 to, di ba? VI to be equal to VD plus V0. Okay? Yes, magkamukha sila. Okay. So, meron tayong ganitong relationship. And if this is my maximum VI, and this is my maximum VD, by this equation, alam ko na yung matitira ay V0. Okay. So, naputol daw ako kanina sa may maximum voltages. Diba? Okay. Kung nandito yung maximum voltage ko for VI, okay, yung maximum voltage ko for VI, then this is the maximum voltage for the VD. Then by KVL, alam ko na yung extra part is for V0. Okay? For V0. Okay, so ayan yung itsura niya. And then, kapag nasa maximum E, not ako, ito yung line ng response yung ID ko. Okay? So, yung ID. And then, syempre, yung source natin nag-oscillate from negative 1 to 1. Ang nangyayari is that your line also moves. Okay? So, kunyari, nandito yung VI ko. Nandito lang din yung line ko. And kunyari, nandito, so on and so forth. Okay? So, meron siyang lines ng response niya. Okay? Okay. Kung mapansin nyo, kapag malapit na ako sa VD, yung intersection ng dalawang same slopes lang kasi yung equation niya something like this, di ba? ID E minus VD, E minus, for this part is E minus V0 siya over R. So 1 over R lagi yung yung tawag dito, slope niya. Okay? Pansin nyo, kapag nandito na ako sa malapit sa maximum voltage ng VD, yung response ko ay wala nang current. Okay? Wala nang current na madadaloy sa akin. Okay? And then, tingnan natin ngayon yung intuitive lang na inspection nitong circuit natin. Di ba yung diode, gusto niya lang one direction ng propagation ng current sa kanya? Okay? Pag nasa maximum cosine ka, so here, kuwari ang maximum ko E, no? Ang mangyayari, this potential here is higher than here. So merong current na magpapass through sa diode ko. Pero kapag nakabaliktad ka na, so negative E na, ang mangyayari, mas malaki yung voltage dito kaysa dito. Okay? Ang gagawin niya, i-open niya yung open niya yung circuit, mapuputol yung connection between these two. Okay. So anong sense nitong lahat ng to? Titingnan natin ngayon ito yung graph natin, di ba? Ito yung source natin. Meron tayong cosine wave. Anong time average nito? This is just, time average nito is just 0. Okay? Kasi itong part na to, magka-cancel lang siya with this part, that part will cancel with the next one, and so on and so forth. So wala tong DC voltage. DC voltage is equal to 0. Okay? Wala tong DC voltage dahil kita nyo naman na alternating current siya. Na ganito, pag ganyan yung source mo, alternating current lang siya. However, kapag tinignan mo na yung voltage at this part sa resistor mo, you can see that yung paggalaw, di ba, yung VI ko gagalaw siya from E0, tapos papunta sa kabilang negative E0, tapos babalik siya, mag-sine wave, magko-cosine wave siya, di ba? So, mapansin nyo, yung dadaanan ng VI, dadaanan din ng V0. Basically, yung V0 mo, nagko-cosine din siya. However, pagdating dito sa part, wala na siyang magiging 0 na lang siya, yung V0 mo. So, yung V0 mo actually looks like this. This is V. This is time. Okay, time. Ideally, kung walang diode, ang mararamdaman nung resistor mo would be cosine wave also. Cosine wave din. Tapos, ang mangyayari lang is less than lang siya dun sa maximum voltage. Okay? Less than lang siya sa maximum voltage. Kasi makikita nyo dito, ganito kakapal yung VI, yung E0, pero yung V0, ganito lang siya kakapal. So, therefore, hindi niya maaabot yung maximum E. And then, at these points, ang gagawin ng diode, dahil yung voltage mo nasa baba na, di ba, naka-flip na yung voltage, therefore wala nang current na magpa-pass through dito. Anong mararamdaman anong voltage dito? Pag nag-open circuit na siya? Di ba, pag nag-open circuit na, ano itsura ng circuit natin? Ganito na. Therefore, nakakabit to sa puwet ng V0. Nakakabit siya sa puwet. So, this is ground. Pwede ka maglagay ng ground dyan. Ang mararamdaman mo dito, 0. So, pagdating niya dito, pag mamamatay na yung diode, mag-0 na lang din yung response niya. Okay. So, yung effective na itsura ng graph niya through time looks like this. Okay? This is time, this is voltage, V0. Okay. Kaya siya tinatawag na half-wave rectifier because yung ginagawa niya, pinuputol niya yung kalahati ng wave dun sa original source mo. Okay. And usual itong circuits na to sa mga devices natin, kasi yung mga outlet natin, di ba, they are in AC source. So yung voltages mo, ganito yung itsura niya. Nag-sine wave siya, cosine wave with 60 Hz na frequency in our outlets. And you want your device to be working with DC kasi mas madali handle yung voltage nun. And to do that, lalagyan mo lang ng diode. Magagawa mo na siyang ganito. Almost DC ito kasi kung kukunin mo yung time average nito, meron kang value na lalabas. So walang nagka-cancel out na voltage dito. Okay? Effectively, meron kang DC na ganito kataas. Okay? Ganito kataas na DC. Okay, kasi pag in-average mo itong dalawa, di ba? kalahati lang yung lalabas. Okay? Okay. So, ayan yung half-wave rectifier mo. Alright. Yung graphical analysis, it's somehow, parang focus-focus lang. Wala kang sinasolve. Tinitingnan mo lang yung, yung effects ng circuit mo. Parang ang unsettling ng nakaka-bother siya na gamitin for a solution. Okay? Now, what you can do is to proceed with another technique, which is piecewise linear analysis. Ang gagawin mo ngayon, alam mo yung graph, di ba? Natuto ka na mag-graph. Natuto ka na mag-graph ng mga voltages mo. Gawin mo ngayon is, gawin mong lines yung mga, gawin mong lines yung mga ginraph mo. Pwede ko itong hatiin na ganito na lang yung graph mo. So, ayun yung essence ng pangatlong technique natin, which is gagawin mo line yung mga bagay-bagay. Okay. Parang focus-focus pa rin, no? So, yung pinakahuling technique natin ay yung matindi sa math dahil formal na siya. Para legit na yung talagang ginagawa natin. Okay? So, yung diode natin for this technique, gagawin mo ideal yung response niya. So, gagawin mo siyang linear. And then, okay, so ganito yung ideal diode, yung itsura ng ideal diode. On siya, okay, ibig sabihin may dumadaloy na current sa kanya. Kapag kapag positive na yung ID mo, may magpo-flow sa kanya na current, malamang kasi positive yung ID, magiging short circuit na siya. And then, kapag negative yung voltage mo, walang dadaloy na current sa kanya. Okay? Yung kaninang example natin for real diode would be something like this. Okay. So, may resistance yung usual diodes natin kasi may curve na ganito. May curve siya, so may slope na resistance. Okay? Dito wala siyang resistance dahil ideal diode siya. And yung symbol for an ideal diode is given by this. Okay, so may square siya na symbol. Okay. Now let's solve this problem. Mag-ano ka dito, KCL ka as usual. E minus VD over R. And then this must be equal to ID. Okay, case number 1. Kapag case number 1, ano mangyayari? Kapag positive si ID, ang VD mo would be 0. ID greater than 0. Ang mangyayari is that mawawala lang yung VD mo. Therefore, you have ID to be equal to E over R. E over R. Okay? Another one. Let's try another case. Yung case na isa would be kapag negative si VD, ang mangyayari, ilagay muna natin yung case. Case 2 would be VD less than 0. Therefore, E minus VD should be equal to 0 yung ID. Ang mangyayari, yung solve ko yung VD, we have this part. Okay, so you have two simplified equations for your two ideal diode. Okay? And then let's try may numerical example. Paano kapag E equals to 3 and then 3 volts and then you have your R to be 500 ohms. Okay. Ang gagawin mo ngayon is to titingnan mo kung saan case siya papasok. Okay, saan case to ito papasok. By inspection, makikita mo na ito ay 0. Pwede mo i-ground tong ilalim. And definitely, ang makukuha mo for the voltage here is greater than 0. Okay? So, definitely hindi na siya pasok sa case 2. So, case 1 na yung gagamitin mo. Then, yung ID mo would be three volts over 500 ohms. Or I can write this as 0.5 kilo ohms. Tamad mag-solve doon. 3 over 1 half. Okay. So this is 6 milliamperes. Okay, tamad ako mag-solve, sorry guys. 6 milliamperes. Gets, i-plug in nyo na lang normally sa calculator na makikita nyo na 6 milliamperes siya. Okay, and then kapag negative 5, another example, definitely makakukuha mo na pag negative 5 doon, mapansin mo agad na yung voltage mo dito ay less than 0. Therefore, case 2 applies. Abandon mo na agad si case 1. Then that tells you that the diode voltage is negative 5. Okay? Okay. Okay. So, ganito yung ginawa natin. Ganito yung ginawa natin sa lab. No? Tinignan lang natin kung paano yung tatingin natin direction ng flow dun sa circuit natin. Then, we can make simple assumptions like this. Parang pangit na example. So, try natin tong isang example. Meron tayong panibagong element dito. We don't know what this is, but ito yung properties niya. Okay? Okay. Kapag negative si VD, ang nangyayari sa kanya, may slope siyang 1 over meron siyang slope na 1 over R2, therefore meron siyang resistance na R2. Okay? Kapag positive si VD, meron siyang slope na R, 1 over negative 1 over R1, then R1 yung resistance niya. Okay? Siyempre, pwede mo rin tingnan in terms of current. So, yung positive current would correspond to R1, and then negative yung na current would correspond to a tawag dito, R2 na resistance. Okay? Okay. Now, ang problem na lang natin dito is to solve. Tingnan natin kung alin yung ID niya. Okay? Is it going really that way? Okay. Or baka makuha natin na ID is negative. Therefore, the current is flowing that way. Okay. How would we know that? I-detach mo siya. Tingnan mo yung Thevenin voltage. Or yung Norton na current. Okay, depende sa kung anong gusto nyo. And let's do that. Okay, mabilisan lang to. So, kapag dinisconnect ko, ano mangyayari? Redraw ko lang yung circuit. Meron akong isang resistor doon. Meron ako current source. And then resistor. Voltage source. All connected to the ground. Tapos, and then, meron akong extra resistor dito, pero pinutol ko na nga siya. Pinutol ko na rin siya. Therefore, wala nang silbi tong resistor na nandito. Okay. Okay. Ngayon, titingnan ko lang yung Thevenin voltage. Okay, so VT, pwede kong mag-superposition ulit. Papatayin ko lang yung tig-isang source. Kapag yung I, current ko, enough ko, ang resulting na circuit would be something like this. So magiging open circuit yung part na to, wala na dyan. And then have this plus minus. Okay. Have this. Something like this. Kapag pinatay ko si I off. And then I have here is ang makukuha ko dito na voltage minus dito. Ito yung unang ano natin, no? Part 1 ng Thevenin natin na voltage is something voltage divider lang nito. Okay, di ba? Voltage divider lang siya nito. So that is something positive. So greater than 0. Okay. Tinitingnan ko lang, ina-analyze ko lang kung paano yung response. Hindi ko muna sinasolve yung actual values para hindi ako mahirapan. Kasi gusto ko lang na malaman kung paano yung current dito. When I know the current here, malalaman ko kung anong resistance niya. And then, next one is patayin ko yung voltage ko. Ang resulting values here would be resistance. Tapos, okay, current source. Current source, and then something like this. Okay, yung nandito sa part na to, pinatay na voltage source, so naging wire na lang siya. Ganito yung itsura niya. And we have to find the voltage here and here. And this is a ground. Okay. So, 0 na agad tong part na to. And yung current mo naman ay positive. 1 milliampere. Therefore, kakalat siya dito, kakalat siya dyan. And assure ako dito na positive to. Positive na voltage makukuha ko dito. Okay? Positive makukuha ko dito ng voltage. Dito yan, 0. Okay. Dahil dito ay ground na voltage na ito. Ground na voltage na ito. And parang kung titingnan nyo, impossible makakuha ng negative voltage dito. Okay? Okay. So, pwede nyo ituloy yung calculation kung hindi kayo comfortable sa ginagawa ko na analysis lang. Okay? Pwede nyo ituloy lang kahit dito sa part lang na to. Okay? No problem. Walang problem dun sa part na. Pero kung gusto nyo more intuitive, tingnan natin. Pwede kong ang mangyayari lang kasi sa 1 milliampere mo, madidivide siya into different currents, okay? Yung isa sa kanila makaka-receive ng mas mataas na current, yung isa sa kanila, yung isang branch makaka-receive ng lesser current. Okay? And positive naman yung current na nagpo-flow doon. So therefore, positive yung potential difference dito. Positive yung potential difference dito. Positive yung potential difference dito. Therefore, positive yung node na nandito. Okay? Okay. So looking at these two, yung Thevenin voltage ko is positive. I have my Thevenin like this, resistance. Nakakabit dito yung weird ko na resistor. Ganyan siya. Ito yun. And, ay nawala yung dinrawing ko. Joke lang. Ayan. And kung positive ito, greater than 0, I know my current flows clockwise. Therefore, ID is positive. Kapag ID is positive, R1 na yung pwede ko i-replace sa kanya. So my circuit becomes like this. 5K. Ay, mali. Okay, ganyan na siya. Resistor, voltage. Magiging R1 na siya. R1. Kung ano mang R1 value yung 3K, 2K, 1K. And bumalik na ako ngayon sa linear circuit. By piecewise linear analysis, kung titingnan ko yung linear response ng ng element ko, then I could proceed to changing them into a linear circuit. Okay? Parang hocus-pocus nung hocus-pocus nung pwede natin siya gawin sa diode, diode. Tingnan natin yung graph ng diode. So ito yung graph ng diode, di ba? Pwede akong mag-linear for this part, pwede kong gawin yon for this part. Pwede kong gawin yon. Dahil mukha na siyang line dito. Mukha na siyang line din dito. Okay. So for these parts, pwede ko na lang siyang palitan ng resistor. Okay. Kuwari, yung voltage ko naman sure na lumalagpas siya sa diode voltage, then I'm sure that I could just replace it with a resistor. So, ayun yung purpose niya. Ayun yung purpose ng ano. However, pag pumunta na tayo sa mga parts na ganito, kung saan matindi yung curve, okay, so hindi natin to pwedeng i-drawing as a line. Okay? So we have to, kapag matindi yung curve, pag ganyan yung curve, oh, ganda ng curve. We have to zoom into this little part. So pupunta tayo sa part na yun. Kapag zoom in mo dyan, mapansin nyo na line na lang siya, di ba? Okay, so at this part, line na lang siya. And we can do our analysis there. So ayun yung pang-apat na technique, yung incremental analysis. And when you go into this region, nawala yung ginawin ko ulit. So kapag yung curve mo ganyan, so pupunta ka into this small region, may gagawin ka mga mathematical abstraction like Taylor series expansion to go to dismantle this curve into different small lines. Okay, so next meeting ayun yung gagawin natin sa incremental analysis. Dahil yung mga linear piecewise analysis, pwede lang siya dun sa mukhang linya. Okay? So, kung gagawin mo sa mga kuwari ganito yung response ng isang bagay, pwede ka mag-linear analysis on these parts, di ba? So, for these regions, you're safe to do a linear analysis. Pwede mo lang silang palitan ng resistor with that amount of resistance, yung curve nila, yung slope nila. However, for these regions, ayun na, doon na tayo magkakatalo. Kailangan may way pa tayo para ma-solve yan. Okay? Okay. Walang ba ano, no? Walang bagong thing. Ganun pa rin naman gagawin mo. KVL ka, KCL ka. Then if you could simplify your nonlinear element to a linear element, then much better. Pwede kang gumawa ng mga superposition and then yung Thevenin and Norton theorem mo. But if hindi mo magawa yan, pwede mo naman siya i-detach. Pwede mo i-detach yung nonlinear element mo, then simplify the linear circuit that is left with you. Kasi kayang-kaya mo yun. Okay? Ayun. Ayun, walang something new. Yung huling-huling topic, ayun yung something new. Yung incremental analysis. So, that's it for today. Sorry, na-DC ako, no? Kasalanan ng globe. Okay. Check tayo attendance dahil ako ay late nag-start. Okay, any questions pala? Any questions muna bago mag-check ng attendance? Any clarifications? Wala naman, no? Okay. Yung bagong part lang for today is that yung mga nonlinear element, wala siyang mga techniques na pinapatay-patay, no? Katulad ng sa superposition. Ayun lang yung wala sa kanya. Pero, ayun, pwede mo naman siya detach lang. Then you can proceed with your life. Okay? Okay. Yes.